Hi, I'm Trev Lucas Spawu. You've seen me in a number of chemistry educational videos, like What's in a Mole? Or What is that mole doing in my beaker? The sequel. Okay, I had a request from somebody who shall remain nameless. Okay, about how do you work on the lab? Okay, since we are dealing with the quarantine of the 2020. Okay, so I'm going to go ahead and I'm going to show you guys step by step how to work this lab report. But I am going to be using fake numbers and I'm using another reaction. But if you can do it step by step, you guys are going to do awesome. So let's get to work. So in this lab, we are decomposing baking soda. Okay, so we're going to heat that up and you are going to have an actual yield, what you physically measured, and you'll have a theoretical yield, which you are going to take your calculator and figure that out on paper. Okay? So let's get this thing started. So if you notice, you have a decomposition reaction. So there's our baking soda, and it breaks down into water in the form of steam, carbon dioxide in the form of a gas. And this is what we're going to actually, measure. Na2CO3, sodium carbonate. That's what we're going to check out. Now, the procedure just tells you how we were going to do the lab and all that. So now we're going to work with the fake equation using fake data, and it's in red. So you'll know not to use it. You want to use the black numbers on your original copy. Okay. Tea break. Okay. So we're going to use, instead of this original equation, you will use that when you figure it out. We're going to use the fake equation. So potassium bicarbonate gets us H2O and CO2 and potassium carbonate. That's our fake equation. Okay, so we're going to work with this, not the original equation. So let's go ahead. So we're going to come up with new data. Again, the red is fake. See, it's written there. Red equals fake. This is the real numbers you work with. Okay? Now, if you already know how to work with the real numbers, go for it. But for those of you, let's work with the red numbers. So the mass of our crucible, our original cup, is 4 grams. We're going to add some potassium bicarbonate, otherwise known as fake baking soda, in there. And we're going to put that in our crucible, our little cup. And we're going to weigh it. We got 4.25. Okay, so now we need the mass of our potassium bicarbonate. Now, guess what? It's now, we take 4.25, subtract 4, so the cup with the powder minus the empty cup, and we end up getting 0.25 grams of potassium bicarbonate. That is before we heat it up. Now, we heat it up, and then we have the mass of the crucible and our potassium carbonate after you heated it up. So we got 4.16. Now, I pulled this number out, okay? Work with me here. So I got 4.16. So now we have that. And it says mass of the Na2CO3 after you heated it up. So in this case, it's K2CO3, right? So how do you figure that out? Well, you're going to take this number, because this is after you heated it up, but you have to subtract the empty crucible. That's why I got 4.16 minus 4.0 equals 0.16 grams. That, ladies and gentlemen, is how much K2CO3 or potassium carbonate we have left after cooking our potassium bicarbonate. Yeah. You can see this coming, can't you? All right, now notice the arrow says this is what you actually got. This is the actual yield. This is what you physically worked with in the lab. We're pretending, remember, we're in a quarantine, and you calculated it. So when you say this is what you actually got, guess what? That's your actual yield. Well, that's an important thing. We got our actual yield now. Yeah. Now we got to figure out the theoretical yield. Now we're going to calculate how much we should get. Now, guys, if we're saying how much we should get, guess what? That's going to be our theoretical yield. Very important idea. So I broke it down into different steps so you guys can see. Okay. So our first one is what is the molar mass, the grams per mole of baking soda? In this case, it's our KHCO3. And we're going to show the work. You got to show the work, guys, otherwise it doesn't count. So here you go. Right here. Okay, so we have our fake formula. We find grams per mole. So I have to go in the periodic table. I need to find how many grams there are in a mole of the potassium, the hydrogen, the carbon, and the oxygens. Now, remember, I got to multiply the oxygens by 3, okay? Because it's KHCO3. So 1K, 1H, 1C, and 3 oxygens. So we add those up and we walk away with 100.12 grams per mole. Yay! Okay, so now we know how many grams there are in a mole of our reactant, our potassium bicarbonate. Now, the next thing we're going to do, we're going to change the grams per mole. We're now going to figure out how many moles of this stuff do we have. Because remember, if you go up to step 2, we're going to change the grams of this, our potassium bicarbonate, into moles. You'd say, wait, we have 0.25 grams. Wait, where did that number come from? Chill, scroll up with me, and there you go, that 0.25. But it says mass of baking soda. Come on. The number is red. I did that on purpose. I'm not working the actual data with you. I'm giving you guys fake data so you know how to do it. I'm not going to fish for you. I'm teaching you how to fish. That's the difference. So you got 0.25. That was the mass of our original potassium bicarbonate, KHCO3. So we're going to bring that in. Okay. And we know that we're going to have to go from grams to moles. So that means we're going to have to divide. But what are we going to divide by? How many grams there are in a mole? And oh, look, it's right up here in the previous problem. Man. So it's going to be 0.25 divided by 100.12 grams per mole. And that equals 0.002497 moles. It's going to be a really small number to start with because we're not working with that much material. So we're going to go ahead and round it to 4 decimal places for this lab. So 0.0025 moles of KHCO3. That's what we started with, okay? Because you physically measured 0.25 grams, and then we worked with it. Okay, so let's move on. So now we're going to change the moles of KHCO3 to moles of K2CO3. Okay, so that's the instructions you got here. Remember, it's in red. Okay, and this is where you're going to have your cross, multiply, divide. I forgot. Chill. Again, I got you covered. Okay. This is a mole-to-mole ratio time, okay? So we're going to look at moles of our KHCO3 to moles of K2CO3. What are we interested in? The moles of K2CO3. Say, but I don't quite get it. Do you remember when I talked to you guys about you had tire rubber and you changed it to the number of tires, right? Then there was a ratio, 4 tires to 1 car. How many cars can you get with all the tires you have? That's the same idea here. we have numbers of KHCO3, and we're now changing it to numbers of K2CO3. It's the same idea. This is like the numbers of tires, numbers of cars. That's it. But we need to look at our ratio. We need to look at the ratio of our equation here. Now, if you notice, do I care about the H2O and CO2? No, they're gone. When we cook this stuff, okay, it went bye-bye into the air, okay? Free as the air. So it won't matter. Now the 2 KHCO3 to 1 K2CO3. Notice this is where I have my ratio down here, right? Now, on the other side, I've got my actual moles of KHCO3. Okay, remember, where did we get that? We got that from the previous problem when we changed our grams to moles of KHCO3. So that's where the 0.0025 moles comes from. Okay, now we're trying to find the moles of K2CO3. That's our product. Now I use the letter Z. Okay, not X, not Y, Z. Okay, and this is the part, ladies and gentlemen, where you are going to cross multiply and divide. Now in this case here, there, we're going to use that. So 2Z is equal to 0.0025 times 1. Okay, so we cross multiply and divide. And what we got here, Z is equal to 0.00125 moles of K2CO3. But it's not the same number of moles as the original thing. You're right. It's half, because there's 2 of these KHCO3s to 1 of these K2CO3s. So that's why this is going to be 1/2 of it. And that's why you got an even smaller number of moles. Okay, so now we know the moles of our product, K2CO3, potassium carbonate. Let's go on, because our next step is we need to know the molar mass of our K2CO3. That's our product. Notice it's in red because it's fake, right? Working with our fake reaction, we are looking for grams per mole of K2CO3. So we're going to go back. We're going to go to our periodic table, and we find this information. So you know there's 2 Ks, 1 C, 3 Os. Okay, so that's going to give us 138.21 grams per mole. Key thing there. Okay, we're almost done. Yeah. Yay. Okay, we're going downhill. We need to find out how many grams of this K2CO3 we've got. So now we're going to go to number 5. And here it is. We're going to change the moles of K2CO3 to grams of K2CO3. And that's going from moles to grams, you multiply. Moles to grams, you multiply. Okay, I got that. So wait, there's the K2CO3. I got 0.00125 moles, and I'm going to grams. Wait, where did that 0.00125 come from? Let's go back up, because remember, we had to change it from moles of our reactant, our potassium bicarbonate, to moles of potassium carbonate. Okay, and we worked all this out, and that's how we ended up with a 0.00125. So now we're going to come down, and we're going to go ahead. We know that we're going to take moles to grams we multiply, so it's the number of moles times how many grams there are in a mole. Wait, where did that 138.21 come from? Right here from the previous problem. See, that's how I broke it down step by step so you can refer to it. And again, that's why I'm making this video, to help guide you through. Okay? It was a personal request from Grandmaster C himself. All right, so we now multiplied it. So our number is 0.17276 grams. We'll round it to 2 decimal places, and it's 0.17 grams of K2CO3. Notice the arrow that I inserted there. This is what you would have gotten in the perfect world. In other words, our theoretical yield. Okay? This is as everything goes great. We did all this time, all the calculations on the paper, multiple calculations. So we get to this point. That's how much we would get in the perfect world. Everything is great. This is our maximum yield that we would get. 0.17 grams. Oh, please tell me it's over. No, it's not over. There is one more step. Just one more. Move on. Now we look at our percent. This is our percent yield. Okay? So for us, it's what you actually got from your lab, see your data table, compared to what you actually got in the perfect world. So in my lab, wait. Where did that 0.16 come from? Okay, let's scroll all the way back up. That 0.16 is right here. This is your actual yield right here. Okay? We're going to scroll all the way down and we're going to take what we would have gotten in the perfect world. Wait. Where did that 0.17 come from? Right here. So you have your actual yield of 0.16 and you're dividing it by your theoretical yield of 0.17 times 100, and that gives you a 94.12% theoretical percent yield. Whew. Yeah. That's it, guys. Congratulations. You've walked through a stoichiometry decomposition lab with your calculations. Now you can go ahead and work on the actual data yourself. You got this because this is step by step. Remember, those red numbers are fake. 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 Fake.